Okay, let's talk about parallax. Parallax is a very important astronomical concept, and that is how astronomers measure star distance. And they do this by using geometry. Oh no, a real-world application of geometry. Maybe you should start paying attention to your math teachers. Well, anyways, what is parallax? Parallax is the apparent shift of an object with respect to what's in the background. So it's a comparison between a near object and background objects, so stars. And they do this by calculating an angle as Earth is orbiting around the sun, and they use that angle to determine how close or far away a star is. Now, what on earth does that mean? Let me demonstrate. So here, let me give you an example. I can demonstrate parallax. I can demonstrate parallax for you right now. So, what I want all of you to do is I want all of you to hold out your finger in front of you, okay? So you're going to, here, I'll do it this way. Let me switch hands. You are going to hold out your finger in front of you, and you will look at your finger, and you will look at the objects behind it. So for me, I have my finger, and behind my finger is the door to my classroom. So I'm going to be comparing my finger to the door. I know the door is not moving, and I know that my finger is not moving. So to get that apparent shift, and that apparent shift is perspective. It's all about perspective, or from a viewpoint. So for me, to get that perspective, I am looking at my finger, and if I look at my finger through one eye, I see it one way. But if I look at my finger through the other eye, through my left eye, there you go, I had to think about that. It's going to look like my finger has moved, even though it hasn't. So let me do that again. Let's see if I can do this without moving my arm. So I'm looking at my finger through one eye, there it is. But if I switch eyes here, it looks like my finger is moving, even though it's not. So let's do this again. So my right eye, my left eye, my right eye, my left eye. Camera 1, camera 2, camera 1, camera 2. Oh, that was a really bad Wayne's World reference. Pretty sure you guys haven't seen that movie, but okay. I can actually, so you have this as a means for demonstration, but I can actually draw that out on paper. So let me draw that out on paper for a better explanation. Okay, so I'm gonna draw out parallax. Parallax, or phonetically, parallax. Parallax. That is the apparent shift of an object with respect to the background. And this is going to be our straight down model. Straight down model. All right? So I'm going to do my best to draw this out for you. The first thing we need is we need our sun. And I'm going to put our sun over here somewhere. Yellow doesn't show up very well, so we're just going to go with orange. And let's draw a line out. Let's try and do a straight line. Let's try. Something like this. There we go. There we go. I think that's a straight line. That looks kind of straight. And I am going to put another star maybe about right there. There's another star. And mind you, this is not to scale. So let's put our Earth, let's give our Earth an orbit. something like that. And I'm going to put our Earth here, so it's straight on, right in alignment. We're looking straight out. And we see the star in front of us. Okay. Now, if Earth were to move in its orbit, if Earth were to move, so we'll put Earth here. Okay, so Earth has moved 3 months later. This star, from our perspective, if we're still looking at the star here, it will have changed. Something like that. And in the background, I'm going to put some other stars here. I'll go like that. Let's draw a red one because I can. Ooh, how about a blue one? I forgot to put background stars down. And then let me put some background stars on the other side. There we go. Something to compare to the background. So we know these stars are not moving, and this is the one that is. All right. 6 months later from this point, so let's put Earth on the other side. We are now going to look at the same star here, and our perspective will have changed. Something like that. And if we were to look at this, okay, so this is a straight down model. From this perspective, so looking at it straight on. So I'm going to put a, let's use another color. I'm going to put a 1 right here. That doesn't look like a 1. There we go. 1. So in number 1, what I would see is I would see the main star, and then I would see an orange star and another orange star. Then I would see a red star, and 2 blue ones. This would be our first perspective if we were looking at this from this angle here. Now, number 2, the second one, here is our second point, and I'm actually going to draw that one right here. So here's number 2. We have now moved. So let me draw our background stars. Let me draw our background stars. So we have a red star and a red star, and we have an orange star and an orange star, and we have the orange star here. If we are looking at it from this angle, this orange star appears to be in the same line as this orange star, so we might actually see it something like this, with this one being the close star. This one being the close star. So from this perspective here, this is what we would see. There's our close star relative to the background. From the first point, we would see our star relative to the background. And from this one here, this is going to be point 3. It's a very sad arrow. There we go. From point 3, now that we have moved, let me draw our background stars. Okay, then I have a red one like this, and a red one like this, and I have an orange one and an orange one. Now our background star is going to appear as if it's over here. So this is going to be number 3. This one is our close star. And for the math, as far as the math is concerned, the angle between here and the angle between here, these 2 angles, this is how they get that geometry involved to determine how far away a close star is relative to more distant stars. Now, I'm not going to bore you guys with the geometry and the math, but that is how scientists use parallax to determine distances of close stars.